All right, so I'm going to be talking about some data processing tools that I wrote over the last couple of years for various projects at Xojo. For me personally, it's really important that I'm always doing something with the product because I can't know what it's like to be in your shoes if I'm not using the product, right? So, and the other thing is, there's a reason I do this. I mean, I don't do it, for the money, right? I mean, I'm doing it because, I love the product. I love building tools that make it easy for people to build software they might not have otherwise been able to build. So, okay, so I'm going to be reviewing 4 problems. Thank you. I'm going to be reviewing 4 problems that I solved with Xojo, converting the documentation, because we converted it from MediaWiki to Sphinx, converting feedback, we went to issues, managing the bug bash, and managing our Pro Plus users' issues. All right, so documentation. So there were 4 problems that we wanted to solve by moving the documentation to some other system. 4 problems that the old system had. First of all, it was ugly. MediaWiki is the engine behind Wikipedia, and it's great for that, but it's not really designed for documentation. We couldn't find another system at the time. We were looking for one, so we went with MediaWiki, but it's really designed for articles, not for documentation. So we need to change that. It really wasn't designed for version control. MediaWiki is great for version control within an article, right? So you can go to some article on Wikipedia and you can see all the edits, right, that have been made, but it's not designed to coordinate edits across many different articles. Each article is an independent entity, whereas in documentation, we make all these different changes to a version of our product, and those all have to be coordinated. So it was really a hack to use it for documentation. The navigation was poor. Again, MediaWiki is designed for you to do a search or take a URL and go straight to a page, but there's really no table of contents. It's all independent entities, whereas documentation for a software product is an encapsulated thing, right? You're probably going to look at a lot of the documentation in a software product, whereas with Wikipedia, in your entire lifetime, you may look at 1% of it, right? So it's just the nature of the beast. The other thing about the way we had set it up in Wikipedia, or MediaWiki rather, is that every single class member was its own page. And that has advantages and it has disadvantages. I think the main reason it got set up that way was the prior documentation system was sort of that way. And so we just mimicked it. But I felt like, when people are examining a class, it's a lot easier if they can scroll through that class rather than going back and forth from different pages. So that was another problem to solve. And then finally, it was only the language reference. And we really wanted all of the documentation to be in a single place, available in the IDE. So that was another one we wanted to solve. So we looked at various systems and we found Sphinx. What we really found was the documentation for a 3D game engine called Godot. And we looked at their documentation and we really liked how it looked and how it felt. And so we said, well, what's the system behind Godot? And it turned out to be Sphinx. And it was a documentation system that was designed to document Python. And we thought, okay, this is for, documenting a programming language, therefore it's probably going to be pretty good for us. So the first thing we had to do is convert from MediaWiki markup to ReStructured Text. So ReStructured Text is the markup language that Sphinx is using, and MediaWiki obviously has their own. So that was the first step. Then we needed to merge all the class member pages into a single page. That was another change we were going to make. Organize all these pages into some sort of table of contents. Fortunately, the Sphinx engine has a model for that, but the pages in MediaWiki weren't organized that way. So I had to create some way to do that. And then it has to preserve every single link, right? So links to pages, images, external links, every single link has to be preserved because we had 6,500 pages. There's no way that that can be done manually. It's got to all be done in an automated fashion. Okay, so MediaWiki markup looks like this. This is just a sample of a page. It's actually from the desktop list box. You've got, for example, the description's got curly braces. You've got these key value pairs, text equals. This is styling for bold. And then this is what the events table, or the beginning of the events table, looks like. It's a dynamic table, which I think we created ourselves, right? Yeah, this was something we did. And again, you've got key value pairs. It knows what the super control or super class is. Then it's a table that's titled events, how many columns it has, and then each event is like this. It's a curly braces with key value pairs, etc. Links are in brackets, so that's a link to the integer page. So, so this is what I was starting with, and what I had to go to was something that looked like this. Very different. Restructured text, despite the table here, it looks a lot more like just a text file. So for example, when you have a section, you just put the name of the section and you just underline it, right? And there's like 5 or 6 different characters you can use for this, and that makes it a section, right? And then you just type the text. Now you can sort of ignore these. What these are is this is a link reference. So this is a link to a spot on a page. So anywhere else in the documentation, I can link to the properties section of this specific page. So ignore that for a minute. And then this is another part of restructured text. It's called a CVS, comma separated values table. You just give it a header, what columns you want. You tell it whether you want specific widths or auto, which means it'll automatically do the widths. And then it's basically just comma separated values. So if you look at this first one, and we'll come back to the values in a second. There's a value, a comma, a value, a comma. There's a check mark there because that's read only, and then a comma, and there's no value after that. And then we go to the next row, right? And inside of these, in this particular case, these are links. So this is a kind of link called a reference. Basically, there's 2 types of links in restructured text. There are absolute links to pages, where you're just saying here's the path to the page. And then there are these global references, and they're just called ref. So this value inside the bracket, or inside the less than greater than, has to be globally unique. And since our classes are globally unique, I can just say, I just named them such that it's the name of the class, a dot, and the name of the class member. And this is the text that'll appear. So on this page, you would just see active, and then in the next column, you'd see Boolean, and then the check mark. Right? But this is what the markup looks like. So I was going from what you saw before from MediaWiki to this, and it all had to be in an automated fashion. So, so I wrote an app called MediaWiki Converter, and this is what it looks like. This is the interface I used. And basically, what you would see on the left-hand side here is all the MediaWiki pages. And they were broken down into sections, so there are namespaces. So there was a namespace pop-up menu. I would just choose the namespace pop-up menu, and then it would list all of those pages. And then, because I needed a table of contents, right, over on this side, I would create the hierarchy. So I could add, delete, and rename sections, basically like little folders. And so that's what all this is. This is all just created by hand. And then once I'd created the hierarchy, I could then go find pages, select them, select where I wanted them to go here, press move. And I was using the SQLite database behind the scenes to keep track of all this. So the SQLite database knew which pages had been moved, where they were moved to, etc. Once I got all the pages in the right spot, then I could tell it to convert an individual page, a whole folder, all of it, etc. And that started the conversion process, going through and page by page. The other thing is with Sphinx, the pages are stored on disk in the same configuration as the table of contents. So when you look at the documentation and you see API and you see resources and you see topics, on disk there are folders with those names and subfolders and documents. So it's just a mapping from the file level. So this was created to manage all that. And you can't see it, but there was a folder I called trash. And basically, pages that were not going to be moved over, I put in the trash folder. So that way it knew to ignore those. So, so this was the UI. So basically, this is a big parsing job. So first thing we had to do is identify the type of page. And basically, a page was either a class page or it wasn't. That's essentially how my parser worked. There were really two paths. It knew how to parse a class page, and if it wasn't a class page, then it had a much more general parser. Because essentially, class pages have a very identifiable structure to them, right? Whereas if it's not a class page, then I just have to look at each thing as I go down the page and try to figure out what it is and change it. So basically, loop, and I'll show you some code in a minute, but if it's a class page, the class pages have tags. Everything on the page is tagged. Here's the description, here's an events table, properties table, here's the see also section, etc. There's all these tags. So I would loop through the list of all the possible tags to get the data, and then parse the data into a formatless data structure. So the idea is that I was basically taking a page, parsing it, sticking it into a data structure, a class that represented a page, right? And then taking that data and writing it out to restructured text, right? So basically get it out of the MediaWiki format into some structure that I could identify as the page and then back out to restructured text. Yeah, and then convert the formatting to restructured text. And then finally, now I've got this page that's in restructured text, and create a new file in the right location based on the table of contents, that left-hand pane or right-hand pane, and write the file to that location. Okay, and then then write the data to the file. Okay, so this is a little bit of the code, the important part. So I had this array of all of these different tags that can appear in the MediaWiki. And one of the things I learned about MediaWiki is that MediaWiki is very forgiving, unfortunately. And all the stuff we did in MediaWiki, none of it was done by algorithm, it was all done by hand. And humans make mistakes, and they vary in how they do things. So for example, you see example here. Sometimes it was equals example, and sometimes it was equals space example, and MediaWiki didn't care. Those were the same as far as MediaWiki. So I had to consider all the different places where they could vary. So what it would do is it would just go down this array and just look for each one of these tags, and when it found it, it would take it out, and then it would go through this loop and basically say, oh, okay, and I had essentially a method for each tag. So, oh, it's deprecated, parse deprecation, pass it the data. Right? So it's got this block of data, it's found, pass it in. If it's any of these say class box, data type box. At the top of the pages in the old documentation, there was usually a box, right? And it had the name of the class in it and all that. Well, the tag was class box or data box or event box, etc. So if it was any of those, they were all formatted the same, so that got passed to parse box. And what each of these parsing algorithms is doing is taking the data, parsing it, and filling it in to a data structure, an instance of a class, right? So basically a big loop, and this is just a tiny bit of the code. I didn't want to bore you with all of it, but this is the meat of what it was doing. Okay. So restructured text. Okay, so now that I've got a data structure, I've got to write it out to restructured text. And again, this is just dealing with the class pages. So the description, it's basically the data is all in this structure. So it's essentially going through and just creating the restructured text. There's a lot of individual routines here. If it's the description, it may have HTTP links in it. It may have internal links. Remember, I had to manage all of the links. I couldn't lose anything because I couldn't do it manually. So internal links converted, basically would take the page and convert all the internal links properly. It handled styles like bolding, etc. And then on a page, you could have a description, you could have a values section, you could have a syntax usage section, and it's just handling all the bits as it goes down. And this went on and on and on and on for all of the different parts of a page. In this case, a class page. So on this project, the lessons I learned were, first of all, move all the data to your local drive. I thought this project's not going to take very long, so what if the server is, in New York and I'm in Austin, right? Well, at some point during this project, I realized I should have created a SQLite database and just written an algorithm to, move every single page from MediaWiki into the SQLite database and then just do it all locally, right? Now, that sounds totally reasonable when you get far enough into the project where you realize this is going to take longer than I thought. And then the problem is you reach that point and then it's like, well, I'm almost at the end, so there's no point in doing it now. Well, yeah, so if I ever did one of these again, when I'm going to be accessing the data over the internet, I would just bring it all locally. Because you could always update that, right? You can get all your testing done, and then, once a month or something, run that algorithm again and load all the data. Because to process 6,500 pages or something, going over the internet, and I have a gigabit internet connection, right? I have AT&T fiber. It was taking about an hour to process all the pages. Yeah, because it's all going back and forth, right? It has to take the page from New York, right? Bring it here, process it, and then send it back, right? So, well, actually, no, it didn't send it back because it was storing it locally, and then I'd eventually upload it. But anyway, it was actually, 9,300 pages. Yeah. So that was a lesson I learned on that project. Determine up front if the source format is forgiving. I didn't realize that, but yeah, like I said earlier, MediaWiki is very forgiving. And we're not used to that with programming languages. We're used to there being a spec and it follows it very closely. That wasn't the case here. So I had to just account for a lot of variation. Find out if the source content is consistent. When I first started doing a few pages, I was like, okay, this is the format, this is all good. But then I'd run into all these errors. Well, yeah, it's because the format wasn't consistent, because it was human beings doing it, and there's 9,300 pages, so there's no way it'd be great if we'd be consistent, but that wasn't realistic. Be prepared for the end result to be imperfect at first. You want it to just do the whole thing and come out absolutely perfect, but again, this is coming, in this case, from content created by human beings, and it's not going to be perfect. But it gave us a really good starting point. It's gotten a whole lot better in the very short time since we made the change with Travis's help on all the searching, which has been great. So that's just something to think about. Now, the other problem we had was links. Links can go bad. You don't know where all the links are to a page. Pages get changed, external links change. And in MediaWiki, we had no system for that. If you just had to notice that a link was bad. They would show up in red if they were bad. So if you didn't notice, then a bad link would just be out there. So I decided that wasn't any good. We needed a system that could check every single link in the documentation at any time we needed to check them. So I wrote another tool for that. This tool is called Docs. It actually it's a growing tool. It does more and more things for our documentation. And basically what it does is you've got source files in this pane, and it's the same exact setup as you saw before. It's the table of contents, essentially, of the documentation. But these are the actual files and file names on the disk. You pick one or more folders or individual files, and you click check links, and it runs through all of the files. It finds every single link, and then it goes and makes sure that if it's a document link, that page exists at that path location, or if it's a global link, that it really does go to the place it claims to go to. So you run it on my computer. It can check. The end result was about 2,400 pages, down from 9,300 or 9,600, and it could check 2,400 pages in about 14 seconds. So this was the reason why I should have brought all the pages from MediaWiki to my computer when doing the conversion. But anyway, so and I'll show you in a minute how I set this up, because I made a fairly generic document processor, which I knew that over time I was going to have more and more methods to do, more and more functions to automate things in terms of the documentation. So I didn't want to rewrite a bunch of that every single time. So I'll show you that in a minute. So after it runs, you end up with something like this. So this is checking all the documentation. There's an error message, bad link, and then you have which link is bad. And I wrote this so that we edit the documentation in Visual Studio Code. So I made this so that when you double click on a row, it launches Visual Studio Code and takes you to that document, so you can then go and fix the link. I may eventually make it try to fix the links itself. I think that might be possible, but we're not quite there yet. So that's how that works. Now, to do that, as I said, I wanted to simplify the file processing. So I created an interface. And when I first saw interfaces, I was not really sure. This is years and years ago. I wasn't really sure what the point was. And then one day it just clicked, because they never existed in any programming language I'd ever used before. So in fact, I almost am hesitant to admit this, but Xojo was the first object-oriented programming language I'd ever used. I mean, I had a little experience with Newton script, right? Because the Newton toolkit was an object-oriented language, but it provided no information on object-oriented programming. They just kind of handed you the environment and hoped you understood how it worked. So anyway, so the file processor interface I created has 4 method signatures. Confirmation question. The reason for that is that when you're about to run a process on thousands of files that might do something dangerous, in some cases you may want to ask the user, are you sure you want to do this? So what this does is if you return a value from this, if you return a string, then before the process starts, it pops up a confirmation dialog and asks, put your string in there and has yes and no buttons, right, or OK and cancel. Okay, we'll skip file message. Well, this returns a list of files. Preprocessor. Sometimes when you're processing a whole lot of files, you have some activities you need to do up front that you just do one time, right? Maybe you need to gather a bunch of data or make a bunch of calculations, whatever it is. So preprocessor will run just once, and then it just goes into a loop for whatever files the user selected and passes each folder item to process file. So the practical upshot of this is that when you need to create something to process a bunch of files in this app, you create a new class, you have it implement the file processor interface, you fill in, if you return nothing from this, it just skips it and it just starts up right away. You fill in the preprocessor method if there's anything you need to have done before it starts, and then you fill in the process file method, which is the meat of that function, right? Whatever it is you're going to do to the file is in process file. So yeah, and then file messages are the errors. So when it's done, it's got an array of file message objects that have a folder item, a message, and a value. So it's the bad link or whatever, and then the URL, for example, not URL, but the path, yeah, the link. So you just get an array of these back so that they can be displayed. So the idea is that you don't have to worry about the progress bar, you don't have to worry about the list, you don't have to worry about what files are being selected. None of that is relevant because that's all handled by my application. All you have to do is create a class, implement that interface, the file processor interface, and you're done, and it'll just work. Oh, and then you just make an instance of it. You literally just have a button or a menu item that says, var X as my file processor class, or my my file class or class. Make a new instance, and it runs because it runs from the constructor automatically. Okay. So for example, so this is a bunch of the processing that's going on in the application right now. So here's the link checker, and it implements confirmation question. It's got another method that's specific to it, get links from files in a folder. So here's the preprocessor. So find all of the destination links that start like this, so we can compare them to the reference links against them in the process file. So, and it's also setting up the interface for the progress dialog. This is a screenshot. Yeah, sorry. But basically, it's just getting the progress dialog ready, passing it some information, like it's an indeterminate progress bar, a heading. Then it calls get links from files and folders, so I can get all the links, because that's a one-time thing. Go through and get all the links so I can check them. And then, and again, I'm not going to go through all the code. I'm just giving you the overall idea. This is process file for the link checker. And this is basically going through, getting all the links, gets the data from the file, gets all the links, loops through each one and checks them. These are the reference links. Then it checks doc links. So these are links to a page, a file, right? Reference links are global. And this is, Ken, where I'm using regex. Yeah, that was if you have not used regex, spend some time, because it's a lifesaver. I mean, the amount you can do in it takes a while to like figure out what the regex thing should be, but once you've figured it out, oh my God, it'll just save you so much time. So this links from data, I can just give it what the different links look like, right? And it could find them. So it's basically going through the global reference links, the doc links, and the image links, and a few others. And so it just processes one file, checking that file for all the links. So the interface simplified things quite a bit. I create a new class. I select the file processor interface. I write the code for the various methods. I add the interface control to make a new instance of the class, and that's it. I'm done. I don't have to worry about progress. I don't have to worry about file selection. It just takes care of all of it for me. Now, another problem I had to solve with the documentation is page creation, because in MediaWiki we did it all by hand, and that introduced a lot of inconsistency. I didn't want to have that happen. So I had to automate it. So I created another app called Doc Page Creator. And it's a very simple looking app, but basically you put in the name of a class and you press parse. And what this does, now this is something that I have the advantage of having the source code to the frameworks. It looks into the source code of the frameworks, finds the class, and then generates all of the restructured text for that class page. So here's just the top of the desktop list box page, but it generates all of this, and it's a big, well, desktop list box is a huge page. It generates the whole thing, and all I have to then do is fill in the description. That's why you see description goes here, and that'll appear at various spots as a placeholder. There's no way to automate that part. But at least everything else is going to be absolutely consistent, because all the user has to do then is fill in descriptions. So that was a big win. So this is the whole page, just so you can see. I mean, it generated all of this. Yeah, and it's still, look at the scroll bar, it's still going, right? Yeah, so now we're into, properties and, all the values, all the links, and that's why I'm scrolling really fast now, so I can just get to the bottom. Yeah, so you can see, description goes here. So it just generates all of this, every link, every section header, huge time saver. Not only time saver, but again, consistency. Okay. So those were some of the apps I created for the documentation conversion, for maintaining the documentation, and for creating new pages. So at first I was going to use introspection for this, but there's some data that introspection doesn't give me. And I think Travis, I think you might have been the person that said, you know, you do have access to the source. I was like, oh yeah, you're right. So oh no, that's what it was. With introspection, I'd have to get a build that had the class in it, right? But sometimes I'm documenting something where I don't have the build yet, right? So, or the build has changed. So with this, I just fetch the recent version of the source and run my app because it's looking at the source code. So that turned out to be a big win. Next was converting feedback to issues. So once we made the decision to switch, the time frame was basically, you know, how quickly could we get all this data moved from feedback into issues. Feedback was based on a Postgres database. So it actually only took a few weeks to get the basic process of converting the data over, but then you know, like anything, like the first 80% takes 20% of the time, right? You got to do a lot of tweaking after that. So I wrote this application. It's called Issues Importer. This is one of those, you know, one-time things. Not a very sexy interface. There wasn't much to it in terms of that. You just pick whether you were working with the test server or the live server, and did you want all the cases, a single case, or cases starting at a specific number. And then you could, once you picked those, you could import, link, or delete. Very simple. Basically, this is just determining the SQL statement I was going to use to search the Postgres database. You know, all, you know, or nothing. Not nothing, but you know what I mean. Okay. So basically query the rows in the feedback PostgreSQL database to import. Feedback, you think well, it's just bugs and feature requests. It's got to be a really simple database. Now, I don't know how many tables it had, but there were a lot of them, and I had to figure out what data relates to what data, and that part was kind of time consuming. And what I'm showing you looks rather simple, but there was like over 70 methods and events to make the importer work. So basically, do the query, loop through each row, converting the data into a dictionary. This is how I did this one. Put it in a dictionary. The keys in the dictionary were the names that the issues API was expecting. So GitLab has their own API. And then convert the dictionary into a payload, because I needed to send it to issues. And use URL connection subclass to send the payload over to the issue server. That's the basic, you know, guts of the application. Now, every time, for security reasons, every time you send something or receive something, or actually I guess just send something to issues, you've got to send an authentication token. That's pretty standard. But the thing that I ran into, I wasn't expecting, is that, you know, if there's a case in feedback and Kem has added a note to it, it says, you know, it's from Kem, and it's got his note. Well, I needed it to look that way in issues, but Kem didn't create it. My bot is creating it, right? Well, fortunately, the people at GitLab figured that out. They solved that problem with something called a user impersonation token. So essentially what I could do is say, okay, I want to add this note to this case, this issue, but I want to impersonate Kem, right, when I do it. That way, when it appears in the issue, it says it's him, it says username, right, and it's got his note. But behind the scenes, the database knows that he didn't really create that note. That note was created by Xojo bot impersonating him, right? But to the user, it looks like, that's how we get the data transferred in such a way as it, you know, looks appropriate. Otherwise, you'd have all these issues and notes and things, and none of it would be from the people that actually originally created it.
In fact, our earlier version did that.
Correct.
Decided how it's not
Yeah,
acceptable.
yeah. Originally, that's what we were going to do. We're like, yeah, no, that won't work. Yeah, so we had to go with this, and that actually worked out really well. I was so happy to find this. It's like, oh, they thought of this. They had to. I think I told Travis they had to have thought of this problem, and sure enough, that was the solution. All right, now. Sometimes we wanted a reference, we wanted to reference a user on a particular issue, And if the user never created an issue, they won't be, their name won't autocomplete, right? Because they're not in the issue system. So I had to make another algorithm, this is the longest name for an algorithm method I've ever created. But I like my method names to be very descriptive, right? Add new users to issues project as guests. So I had to have guest permission. So that was solely there so that when you went to, tag a user, anyone, tag another user, and you started typing their name, it would autocomplete and it would work, right? If they had never logged into the issue system yet, if they hadn't done that yet. And most of our users don't. People think that everybody's on the forum, for example. No, most of our users are not on the forum. Most of them never go to the forum. Maybe they read it anonymously, but they don't log into it. And it's the same is true with issues. Now, when your app, or I guess it's the IDE, when the IDE crashes and you get that dialog and it says, do you want to report this, right? That had to be rewritten. So I created a console app for that. And basically what it does is it passes an email address, a crash report title, and a description. That's all from a dialog box in the IDE. And then it looks for a matching title in the issues system and adds the report as a note if it finds a matching title. If not, it creates a new issue. And same thing, it uses authentication and user impersonation tokens because it needs to look like it came from you and not from Xojo bot, which is the name of our bot that runs behind the scenes. And this one is a console app. It was 25 methods, events, and some properties. Now, we also build our release notes directly from our data. So that was another thing. If you go to the documentation, you see a release notes page. We don't do that manually. I think we did in the past at some point, but creating that by hand is a nightmare. So I wrote this release notes builder. It's also a console app, and it's part of our automated build system that runs about once a day. So it looks for issues assigned to the release number that's been passed, filters out only the issues that have a release note. You'll notice, by the way, if you look at issues, you'll see notes that say it's bracket RN bracket, and then there's some text. That's the tag that we use to indicate it's a release note. Creates the page for the docs with all the formatting, as you see when you look at release notes. And it's about 11 methods. Okay, managing the bug bash. So as you know, you nominated cases for the bug bash. You put in bug bash 2022 nominee on a note. And we need to automate the process of adding the bug bash label to those individual issues. So it's another console app. You basically pass in the qualification date because we wanted cases that are after a certain date to qualify. Find nominated issues that are still open and don't have a bug bash label. Create a unique array of the authors of those issues. Basically, we don't want someone to have a bug bash label on more than one issue at a time, right? So loop through the nominated issues and make sure the author doesn't already have an issue with a bug bash label. Finally, make sure that the issue wasn't previously nominated and then have the bug bash label. So this ran constantly and basically made sure that anyone that nominated an issue only had one issue with the bug bash label at a time. So when we closed a case and it had a bug bash label, then it would go find another one of your cases that you nominated and had a bug bash label. And then finally, our Pro Plus users, we want to make sure that anyone on the Xojo team that's looking at the issues recognizes any issues that are from Pro Plus users. And so I wanted a system to take care of that automatically. So I wrote another console app for this purpose. So this would go to our e-commerce system and get a list of all the Pro Plus users. then it gets all the open issues that already have a Pro Plus label. And if the author is not currently a Pro Plus user, it removes the label. Then make sure every other open Pro Plus user case has a label. So this was all the stuff I've been writing over the last couple of years to manage the conversion to the new documentation system, to manage the conversion to issues, setting up the users for issues, and then the crash reporter to deal with crashes, release notes builder, bug bash label, Pro Plus labeler. These last 4 or 5 are console applications. And honestly, I'd never written a console app before. Never needed one. I mean, my apps all had user interface and stuff like that. But it was a lot of work, but most of it really was understanding APIs, understanding data formatting. But I also took the time, like with the Docs app, knowing that over the next many years, I'm going to do more and more automated processing of the documentation to make that, as I showed you with the file processor thing, so that it's very, very simple to create something new that I can apply to any number of pages and keep it all consistent. For me, as the CEO of the company, it's just really important that I keep using the product. I'm involved in a lot of meetings about design, and we're making decisions about implementation and things like that. But I need to be using the product. They use the product when they're building it, right? So I need to be using the product as well. So that's why I take on tasks like this, because I'm not just the founder and CEO, I'm also a user. So that's my presentation. I've got 13 minutes left, I think. So if there's any questions, this is really a case study, but yeah, Mark, go ahead. Yeah, so now every time there's a new class that needs to be documented, once the engineer has checked it in, then I just need to update my source. I just do a fetch and whatever and update my source. And then I run that application and type in the name of the class, and I've got the page. So then it's just copy and paste into a document, start putting in descriptions. I would love some way for the engineers. Well, actually, let me back up. Our process is that the engineers, I'm going to actually switch classes now. Our process is that the engineers write API proposals. So I can go to the original API proposal they wrote before they implemented anything, and if the process is working 100% perfectly, then all of the class members will be there with all of the descriptions, and I can use that as a basis. So that's just a copy and paste job, maybe do a little editing, and then I've got a page. Well, no, that's something I'll do regularly, right? Because I basically have a copy of all the source, and every time a new class gets added, right, I can fetch the source and then just have my application search the source. That's really what it's doing. It's searching the source and generating the page.
Couldn't you have standardized documentation from the very get-go using an app?
We could have. That's true. Yeah. If I had that kind of foresight. But honestly, if I had the foresight to anticipate everything that I would need in the future, this is not what I'd be doing. I would be making, zillions of dollars in the stock market or something. Yeah, I mean, hindsight is 20/20. Yeah. And believe me, I felt that way when I realized if I had just moved all the pages to a SQLite database, I wouldn't have waited 45 minutes. It started like 15 minutes, and then it kept growing and growing and growing until it's like an hour. So, yeah.
So issues was the old feedback was a dynamic system. I don't recall if you shut it down for.
We did. Yeah, a weekend, right?
Yeah, I think it was a total of 3 days.
Yeah.
We had obviously obviously made a lot of plans to keep that short and
Yeah.
had all of this ready to go.
Yeah.
But we did have to turn it off, so it was a exact copy when
Yeah.
it turned on.
Yeah, yeah. So we had to do a lot of testing because that was going to be a one-time
Yep.
thing.
When it's on your user interface, you can have a number, you would pick up from that.
That was really just for testing. Yeah, that wasn't. Yeah. At the end of the day, I clicked all, crossed my fingers, and pressed the button. Yeah. So, but it worked. So, anything else? Okay. Thanks, everybody.